Okay, so now we're moving on to section 1.3, complex numbers, aka imaginary numbers. I kind of like them because you can say you're working with imaginary numbers and it's not that hard. Imaginary numbers came from the square root of a negative number that has the square root. So we know that the square root of 121 is 11. And before, if there was a negative under this square root sign, we would say that this is not a real number, which it is still not a real number. It's an imaginary number. So the square root of a negative 121 would be 11i. Because the I is the root of a negative number. So the square root of negative 1 is I. And if I had I squared, it's going to give us this negative 1. If I had the square root of negative 49, it's now 7i. If I had 7i squared, it's going to be negative 49. So that's the crash course in imaginary numbers. The first two things they want you to do is add and subtract with your imaginary numbers. And one thing you have to remember on all of these is that they want you to keep your answer in the form A plus BI. So regardless of what it is, this isn't like normal binomials where we'd put our unknown, our x values like in the front. I is always going to go at the end. And if you do not type it in this way, MyMathLab will not take it. So here we go. On this one, since we're adding these two, we're going to have 9 subtract 3i plus 5 plus 5i. So 9 plus 5 would give us 14. And negative 3 plus 5 would be plus 2i. And you'd have to write it 14 plus 2i, not 2i plus 14. And that would be the answer to that one. So they're not terrible. They're just different. On this one, since we're subtracting, it's the same as subtracting a normal binomial. We have to multiply by negative 1 so that we change these signs. So we'd have negative 9 plus 8i subtract 2, negative times the negative, plus 3i. Negative 9 subtract 2 would be negative 11. 8i plus 3, 8, 9, 10, 11, so plus 11i. And you would leave it negative 11 plus 11i. And that's all I have for the first page. So I'll stop.